Dr. Hassan is here with the very final lecture for chapter 16 of kinematic of rigid bodies about relative acceleration. So again, I'm here. You can just look at me on the top right corner of your screen. The lecture is I'm going to just start with very basic equation about relative acceleration. Acceleration of B is equal to acceleration of A, again, plus two components. One of them is the component due to AT, which is alpha cross R, and then the second one is from AN. So AN, we're going to show it with minus omega square R, or I can say that minus omega square R. In this case, I'm going to say B, so this will be alpha of AB, R will be RB with respect to A, and omega will be omega of AB, and R will be RB with respect to A. So if I know acceleration of, if this is a rigid body, I know acceleration of A, I'm going to say acceleration of B is equal to acceleration of A, same as that, plus 2 that's coming from rotation. One is coming from alpha, the other one is coming from omega. So in this body that I have, I'm going to assume that I have omega like this, I have omega AB, and I have one more on the top of that, which is alpha AB. So if you have alpha, again, alpha is angular acceleration, omega is angular velocity. I can simply calculate the rest of them. So in this equation, alpha is a vector, of course. Come back. Alpha is a vector, R is a vector, omega square, this is just a scalar, and then down here is a vector. So let me just start from a very basic problem. In a very basic problem, I have a rotational, I have a wheel, the center is fixed, that's point A, and then I want to find acceleration of point B at the angle of 30 degrees. The radius of this wheel is 0.5 meter, omega and alpha. So alpha is equal to 2 radian per second square, and omega is equal to 3 radian per second. Now there are two ways I can solve this. One way I can just use the AT, and AN, because this is rotation about fixed point. But the problem with that, that's going to give me AT and AN, but not going to give me an IJ component. It's going to give me just a value. So what I'm going to do is that I know acceleration of point A is 0, because that point A is fixed. I'm going to write the equation I have all the way up there. So this is omega AB, and this is alpha of AB. So I can say acceleration of B, point B, is equal to acceleration of point A, plus the rest of them is going to be repeated there. So acceleration of point A is simply 0, because point A is constant, it doesn't rotate. Now alpha and omega, both of them are rotating clockwise, so both of them are negative. So I can say for alpha, I'm going to say minus, so I can let me just to put plus. The alpha is actually minus 2k. Why put minus 2k? Because it's rotating clockwise. RB with respect to A, I need to find that. So RB with respect to A, assume OA as your origin, right? If you assume A as your origin, where point B is located? So something looks like this. If this is origin, which is point A, point B is located at the distance of, so down here we have 0.5 cosine 30, up here we have 0.5 sine 30. 0.5 sine 30 will be 0.25, 0.5 cosine 30 will be 0.433. I'm very genius. I'm joking. You know that cosine 30 is 0.866, so half of it will be 0.433. Now, if I look into point B with respect to point A, I can say that on the X is negative, on the Y is positive. So I can say RB with respect to A is equal to 0.433I, and that's actually negative. And then for the Y will be plus 0.25J. And we are good. So I found RB with respect to A. I'm going to just simply plug it in here. Now again, I'm just going to show you the equation there. RB with respect to A, which is minus 0.433I plus 0.25J, and lastly is minus omega square. So the value for omega is zoom it a little bit. The value for omega we found it is 3. So 3 to the power of 2 will be 9. So it will be minus 3 to the power of 2 times the same thing that we have here, minus 0.433I plus 0.25J. Now all I need to do, I just need to simplify this equation. Now in this simplification, I'm going to get acceleration of B is equal to, so I have minus 2 times, so you have a minus here, and then you have another minus 0.433 K cross with I. The next one will be plus K cross with J. Now let's work on this. So I'm going to go up here again. I talked about that in the previous lecture. I'm going to do a review again here. I, J, K. I cross, again in this arrangement, I'm going to assume that counterclockwise is positive. Because counterclockwise is positive, you can say I cross J will be K. Now in this case I have K cross I. So K, if you go from K to I, you are going in the counterclockwise position, so you're going to get positive J here. So K cross I is positive J, and then the next one we have is K cross J. So K cross J is going to go the opposite way. So because J cross K is I, but K cross J will be negative I. So this will be negative I, and this thing is going to be simply J. So I'm going to repeat the rest of them. So I have minus 9 times minus 0.433 I, and lastly will be minus 9 times 0.25 J. So all you need to do, you need to simplify it and then get your answer off of there. So now we have minus 2, minus times minus will be positive, so I'm going to get plus 0.866 J. Next one, minus 2 times 0.25, and then you have minus I there, right? So the answer is going to be plus 0.5 I. 9 times 0.334, I don't know, I'm going to just leave it as the way it is. And last one is minus 9 times 2.5, which is actually 8 of them will be 8 of 2.5 will be 2, so it will be 2.25. So 2.25 J. Now you can simply add the I together and add the J together. But remember, this is actually your AT, and this is going to be your AN. If you add these two together, you will be able to find acceleration of point B. That much simple. So I want to solve right now it's a problem slightly challenging, right? So to solve this problem is slightly challenging. Again, the one I solved was just one rotating wheel. The one I have is more components are going into there. So in this problem, the question asks me to, let me just do a little bit enlarge it so you can read through the problem. At a given instant, the wheel rotates with angular motion shown. So if you look at the wheel itself is going to go with 8 radian per second and then 16 radian per second square. Now at this instant, the question asks us determine the acceleration of point A at this instant. Now if you look at this picture, you would figure out that the A is moving actually to the right, but acceleration I have no idea, and I need to calculate it. Now let's start from one point. We can actually proceed from that point, and that point actually I'm going to call this one point O at the center. Okay, so help me with writing this equation. We can say AB is equal to AO, okay, plus alpha or OB, whatever you want to call it, alpha BO cross with RB with respect to O minus omega squared. The omega here is just a scale. BO times RB with respect to O. I need to find RB with respect to O. This is very similar to the problem I solved before. This is point O, this is point B. RB with respect to O, meaning that this is your origin. If this is origin, you would see now the radius here is 0.15. So now I got 0.15 as the radius for that location. So actually this distance here, where it's going to go from down there, so I have like 0.125 here. Sorry, 0.15 down here. That's the distance from here to here. In order to find the x, so the x will be, and the angle is 30 degrees. So this will be 0.15 cosine 30, and this will be 0.15 sine 30. Then you can say RB with respect to O is equal to, so how much, if we go from O to B, we go 0.15 sine 30. So, and then that's actually be about, let me just write this one down, 0.15 sine 30, that's 0.075. And then the other one down here, 0.15 cosine 30, that would be 0.15 cosine 30, that is 0.13, and this is 0.075. So if I go from O to B, I'm going to go back in the I as 0.13 I. On the Y, I'm going to go plus 0.075 J. You go up. So we found one, and then the other one which is given to us, omega is given to us as 8, alpha is given to us at 16k by the way. This is going to go negative, so that will be negative 16k. Because it's going to go clockwise, right? That's the whole reason that we're going to put it like that. So I'm going to say acceleration of B is equal to acceleration of O, then acceleration of B is equal to acceleration of O, which is 0. Next one plus, that's minus 16k, RB with respect to O, minus 0.13 I plus 0.075 J. Now I have this two. I'm going to move on. Next one is minus omega square. Omega square is 8 to the power of 2 into minus 0.13 I plus 0.075 J. So let's simplify it. So I can say acceleration of B is equal to, I have K cross I down here, and up here I have K cross J. Just I'm gonna draw the little guy here as a reminder, I, J, K. I'm gonna go this way. So K cross I. So if you go from K to I, is gonna be positive J. That's easy. Then k cross j, I'm going to go from k to j, so that will be negative I. So if I simplify this, I'm going to get minus 16 times minus 0.13. I have k cross I, which ended up as j. The next one is plus minus 16 times 0.075 times minus I. And lastly is minus 64 into minus 0.13 I minus 60, we'll put 8, 64, and then okay, minus 64 into 0.075 j. Okay, so I already have all this statement here. I'm going to summarize it. So if you summarize it, you would ended up at something look like this. Again, you have to add the i's together and add the j's together. So if you add the i's together, j's together, you ended up to this equation. Acceleration of b is equal to minus 7.1 I minus 6.88 j. So I found acceleration of point B. Now the question asks me to find acceleration of point A. So I'm going to copy this shape again because I'm going to need this, and then put it down here to work more on it. So from A to B, if I go from, I want to go from B to A. So I want to go from B to A. I'm going to say acceleration of A is equal to acceleration of B plus alpha AB cross with R A with respect to B and then minus omega square AB times RA with respect to B. RA with respect to B, that's just a position vector that describe how, if I go from B to A, how much I'm going to go up. So if you go from B to A and then the angle is 60 degrees, the length of BA is 500. So I'm going to have a picture like this. The length of this guy is 500, which is equal to, I'm going to just leave it as 500. So then, yeah, because the other one I used as millimeter, I'm going to use this one. We use that as meter. I'm going to use this one as a meter too. This will be 0.5 meter. The angle up here is 60 degrees. Now, if you go from point B to point A, that's what I'm looking. RA with respect to B. Point B is the origin. Origin. Now, if I go from that, what's going to be each side of it? The x side is going to be the sine, the y side is going to be cosine. So this will be 0.5 cosine 60. Down here is going to be 0.5 sine 60. If I simplify this, I'm going to get RB with respect to A as, sorry, RA with respect to B is equal to, if I go from B to A, I'm going to go to positive in X and positive in Y. So 0.5 sine 60, that will be, don't know, let me just do the calculation for that. Okay, so sine 60 will be 0. I knew it already, 0.433 I plus 0.25 J. So if you go from A to B, that's how much the R is going to be. Now, alpha AB, I don't know. Omega AB, I don't know. So I ended up with the equation that both of them I do not know. All I know acceleration of point B, but I do not have any further information other than that. So how should I deal with this situation? So acceleration of B, I already know it. And then what I'm going to do, I'm going to do the same thing that we did for the lecture for relative velocity, and we use the vector approach. I'm going to follow the same method. So in the same method, I'm going to say acceleration of A is equal to acceleration of B, that I already know it. So that's actually minus. Now, what I can do, like I do not know omega AB, but I can find it, right? So how can I find omega AB? We can find it use the center for zero velocity. Yeah, of course I can find omega AB. If I know omega AB, because in this problem I do not know this one either. I don't know acceleration of A either. But all I know acceleration of A is in the direction of I. That's everything I know. I don't know anything else. And because acceleration of A doesn't have any component on the J, as the bar here, it's just going to go this way only. So let me just to add another screenshot of the picture to here, allowing us to do some calculation for finding omega AB. So I need to find omega AB. Help. So just to find a screenshot of this guy. So acceleration, I want to find omega of AB. I'm going to go with the concept that we talked already. We call it the concept of zero velocity. Then in this concept, if you look into the bar AB, the velocity of point A is going to be something look like this. Velocity at B is simply perpendicular to the line of action. So the line of action here is going to be something look like this. So you ended up, your velocity is in this direction. So the velocity of point B is along the member AB. The reason for that, because it's perpendicular to the line that's coming from point O, right? So velocity of point B. In order to find where the center for zero velocity is, we need to go perpendicular from every point. So I'm going to go perpendicular from the first point, so perpendicular from this point, and I'm going to go perpendicular from the other point. So let me just to change the pen so you can visually see it. So perpendicular to velocity at A. So the center would be somewhere here, right? And then if you continue this from the other side, you can continue like this. You would end up at a location like this. So now angle here is 90 degrees. How much angle up here is? Again, we know up here this is 60 degrees. The angle here is going to be 30 degrees, 30, 60, and this is going to be 60 degrees. Now what length we know? We know the length from here to here is 0.5. We have two ways to solve this. Either just use a simple trick because you have like a right triangle, or the other thing I can do, I can just use law of sine. So I'm going to use law of sine. In the law of sine, I want to find, I'm going to call this one RA. I'm going to call this one RB. So funny, we have O here, but this is actually center for zero. I'm going to just call it center. So RA and RB, I need to find it. But I already know one side of it, right? So because I know one side of it, let's just write this law of sine. Law of sine is saying that R is going to go with the angle, and then so RA is across from sine 90. So I can say sine 90 over RA is equal to sine 30 over RB is equal to, lastly is the 60, right? And then will be 0.5 over sine of 60. Now if you use your knowledge and then cross multiply them, you would get for RB. So if you cross multiply this, you're going to get for RB is equal to 0.866, and then you're going to get for RA is equal to 1.73. I'm going to go with the same equation that we know from before, that VA is equal to RA omega AB, and then same thing, VB is equal to RB omega AB. So I already know VB. VB we calculate it as, actually I didn't calculate it, but I can simply calculate it. If you look into this location, that's VB, right? This guy is going to go with 8, and then I'm sorry for drinking water. So this distance is 0.15. VB will be equal to R omega, which is 0.15 times 8, and then that's going to give me VB as 0.15 times 8. The answer is 1.2. So this is equal to 1.2 meter per second. So I know velocity of B, then velocity of B is 1 point down here. Velocity of B is 1.2 is equal to RB is 0.866 omega AB. Then from here you can say omega AB is equal to 1.2 divided by 1.2 divided by 1.38. 1.38 radian per second. So I can find velocity of A. Then velocity of A would be equal to, then I'm going to plug it in here, is equal to RA, which is 1.73 into 1.38. 1.73 times 1.38. So I got 2.388, which is almost 2.39 meter per second. So we know velocity of A, and then actually I was looking for just omega AB. I don't know why I calculated that. Omega AB is 1.38, and I already know it. So let's use this in the equation that we have from before. So then we'll do a couple of substitution to solve the problem. So I'm going to zoom out. I need some of those information. So on that equation, I have acceleration of A, which is equal to acceleration of B. Acceleration of B, we found it as minus 7.1. Again, I'm going to zoom in again, don't worry. 1I minus 6.88J. So this is acceleration of B. The next thing I have is plus alpha AB that I don't know, cross with RA with respect to B. RA with respect to B, I found it as 0.433I plus 0.25J. And last one is minus omega square AB. So this is actually going to be 1.38 to the power of 2. That's omega of AB. And then just to write the rest of it underneath, because I'm going to go out of the zoom. So minus and this is omega AB times 0.433I plus 0.25J. Now again we need to go with the calculation that we had. Keep in your mind that alpha AB has a direction, and that direction, like in this case, I do not know. It's going to be positive, it's going to be negative, but I know it's in the direction of K, right? Because that actually is perpendicular to the surface that we are right now in. If you look into the picture one more time, you can see that A is just moving to the right or to the left. So AA, instead of writing AA, I'm going to put AA as acceleration of A in direction of I plus 0 in J. Acceleration of A doesn't have any component on the J. Everything for A is simply on the I. So let's simplify this equation. First one, it just has I and J, so no simplifying needed. I'm going to just change the pen for the... So I have K cross with I. So K cross with I, which is equal to J. The next one I have K cross with J. We discussed this about how we did the calculation. Now, if I go further from here, so I'm going to get into K cross with I. Now, I can actually jump into the solution, but before jumping to the solution, I'm going to end up with something like I'm going to end up like add the i's together in one side and then add the j together to the other side. So in this side, I have AAI plus 0j. In the other side, what I have for I have minus 7.1 here. The next one I have for I is this guy, the guy over there. So that's actually, there is a minus in there, so it will be minus alpha of, yeah, the arrow is not an alpha, the arrow is on the K. So it's minus alpha AB times 0.25 and then the next one is minus 1.38 to the power of 2 times 0.433. That's everything for the I. And what I have for the J? For the J I have plus, okay, for J I have minus 6.88. The next one for the J I have this component, which is 0.433 alpha of AB. And lastly is minus 1.38, so which is actually the component down here, the very last one, minus 1.38 to the power of 2 into 0.25, all this in J. Now if you simplify these two equations, you can say all this has to be AA, all this has to be 0, right? Because this is going to go to this and this is going to go to this one. Then you can solve for AA. First you can solve for alpha AB from this equation, and then once you found alpha AB, how much alpha AB is, you can actually substitute it in the other equation to find how much A of A is. Thank you very much for listening to this long video. I hope any of you that you actually watched the video to this minute, YouTube will send a gift to your house, because no one will actually watch such a video for such a long video. Okay, thank you very much for watching. Bye bye.